AB Calculus Note Card 25 Vertical Tangent Lines. This is the 25th lesson in the series inspired by Stacy McMullen, formerly of the Dallas Independent School District, who developed this note card system. To find the point or points where f of x has a vertical tangent line, find f prime of x, or the first derivative, and set the denominator of that derivative equal to 0. And then we solve the value of that denominator for x, and then we have the x value at the point of tangency and substitute that x value into the original function to find the y value of the point of tangency, and then we have an xy coordinate pair. And we have a few problems that are going to demonstrate the application of finding a vertical tangent. Let's see. Okay. For each of the following, find the point or points, if any, where the relation has any vertical tangent lines. And so the first one we have is g of x equals 3 minus the cube root of x. And for that, I'm going to translate this function into what I call calculus-friendly form, where instead of in terms of radical, we have a rational relation. So that's going to be minus x to the 1/3 power. The cube root means to the 1/3 power. And then continuing to the right, differentiating, I say g prime of x is equal to the derivative of 3 is 0. So we're going to have negative, and then we bring this fraction 1/3 out front, and we're going to have x to the power of 1 minus 1/3, which is negative 2/3. And now I'm going to be working below here. So g prime of x, we're going to change this back into radical form. We're going to have negative 1 over 3, and then we're going to have the cube root of x squared. And now, setting the derivative equal to 0, we say 0 is equal to 3 cube root of x squared. And we should be able to unbundle this pretty quickly and see that x is going to be equal to 0. And so our point of vertical tangency is going to be the coordinate pair 0 comma g of 0. And for that, we go back to our original function. G of 0 is equal to 3, because we substitute in 0 for x, we don't get anything. So we have the point 0 comma 3. And that is our point of vertical tangency, 0 comma 3. Next, problem 2. We have f of x equals the square root of quantity 4 minus x squared. So I'm going to continue to the right and write this in calculus-friendly form. We have f of x equals, we have 4 minus x squared to the power of 1/2, because the square root is the power of 1/2. And then working below, f prime of x is equal to 1/2. We're going to have this 4 minus x squared to the power of 1/2 minus 1, which is the negative 1/2 power, times the derivative of the inside here, which is going to be negative 2x. And so, just simplifying, we have 1/2 of 2 will cancel each other. So f prime of x is equal to negative x over the square root of 24 minus x squared. And then setting the derivative equal to 0, I'm going to just come up here like this. I will say 0 is equal to square root of 4 minus x squared. And then if we solve, we can square both sides. We get 0 is equal to 4 minus x squared. X squared is equal to 4. And square rooting both sides, we have x is going to be equal to plus or minus the square root of 4, which is 2. So our points of tangency, okay, points of vertical tangency are going to be the points 2 comma f of 2 and negative 2 comma f of negative 2. So f of, from the left here, f of 2 is going to be square root of 4 minus 2 squared, which equals 0, and f of negative 2 is going to be square root of 4 minus negative 2 squared, which also simplifies to 0. So our points of vertical tangency are going to be 2 comma 0 and negative 2 comma 0. And I think this looks like a semicircle when you graph it out. Okay, the last one we're going to be looking at comes from an actual year 2000 A/B test. I think this is the 5th problem. Consider the curve given by xy squared minus x cubed y equals 6. And this is an implicit differentiation, which we went over in note card 24. So we have, I'm going to make this a product x and y squared, and this x cubed times y, I'm going to make that a UV product rule situation also. And so implicitly differentiating, we're going to have u times the derivative of v, which is going to be 2y dy dt, and plus v, which is y squared, times the derivative of x, which is going to be dx over dx. And now this second part here, we're going to have u, which is x cubed, times the derivative of y, which is dy dx, minus y times the derivative of x cubed, which is 3 times 3x squared dx dx, and it's going to be equal to the derivative of our constant on the right side, which is 0. Now we're going to take dx over dx. We'll cancel any place we see that. And anything without dx dx, we're going to, without dy dx, we're going to subtract and put over on the right side. So we're going to subtract y squared, and we're going to add 3x squared y, and do the same thing on the right side, 3x squared y, and minus y squared. And now on the left side, we're going to factor everything we have here. I'm going to put the minus sign down here. That's what I'm going to do, just kind of organize a little bit. Okay, now we're going to go ahead and factor out this dy dx. So the left side we have dy dx times quantity 2xy, and we're going to have minus x cubed is equal to 3x squared y minus y squared, and then we're going to divide by 2xy minus x cubed, 2xy minus x cubed, and so canceling, we have dy dx is equal to 3x squared y minus y squared over 2xy minus x cubed. Now we're going to find our x values of tangency by setting our denominator equal to 0. So continuing below here, we're going to say 0 is equal to factoring out an x times quantity 2y minus x squared. So we know that x equals 0 is going to be one of our answers. So we'll have the x-coordinate x equals 0. We know that's one of our answers. And the next thing we're going to have to do is take this, and I'm just going to say also 2y minus x squared is going to be equal to 0. And so y minus x squared is equal to 0. Okay, so 2y is going to be equal to x squared, and so working right here we have y is going to be equal to x squared over 2. So now we're going to come to this original function here. I'm going to work below. We're going to have xy squared minus x squared x cubed y is equal to 6. Now substituting in for y, x squared over 2, so we have x squared over 2 squared minus x cubed, and we're going to have x squared over 2 for y is equal to 6. And distributing here, we're going to have x squared squared times x, and that's going to be x to the 5th, and that's going to be over 4 because 2 squared is 4, minus we have x to the 5th over 2 is equal to 6. So what we have here is, let's go x to the 5th. So we have negative x to the 5th over 4 equals 6. And then multiplying through, and we can trade our negative signs. I'm going to just work to the right here. We're going to have, I'm going to multiply by -1 and get x to the 5th over 4 equals -6. And then multiplying through by 4, we get x to the 5th is equal to -24, and x is going to be equal to the 5th root of -24. So x equals 0, x equals -5th root of 24, and this will be our, okay, x coordinates at point of vertical tangency. That'll be these values right here. X equals 0, and x equals negative fifth root of 24. So good luck, and thanks for viewing.